2 days ago, we learned about a concept called conservation of momentum. The word conservation means stays the same. So conservation of momentum infers that momentum stays the same. In a collision in which we have an isolated system, what does that mean, isolated system? That's important here. What is an isolated system? Because this doesn't work if you don't have an isolated system. That's a system in which we have no external forces. If we have a system with no external forces, that means the total momentum will remain the same. It's conserved. It stays the same. In other words, Pi is equal to Pf. Now, I want to take you back a few days to impulse. We were talking about impulse. Two objects collide with each other. Impulse, change in momentum. Both objects, we said, experienced an equal and opposite change in momentum, an equal and opposite impulse. How do we reconcile that? How do we say that there's an impulse or a change in momentum a week ago when we were analyzing these questions, and now we say that the total momentum stays the same? Well, in the end, what it boils down to is your frame of reference, what you're looking at. Last week, we were looking at individual objects within the system. Object A experiences an impulse. Object B experiences an equal and opposite impulse or an equal and opposite change in momentum. If we look at the system, which is what we're doing this week, the whole thing combined, assuming it's an isolated system with no external forces, then the total momentum will remain the same. Individually, there'll still be an impulse, but the total momentum will remain the same. We'll say Pi is equal to Pf. Now, once we recognize that, we have to elaborate on that, right? We have to write down some terms into this equation. So in other words, Pi, what is it? Well, if you have two objects, it's m1 v1 plus m2 v2. If there's 13 objects, then you keep going until it's m13 v13. Do the same thing after the collision, and then you sub in your numbers and solve. Hey, a couple of things you got to watch out for. You watch out for your signs, north, south, east, west. Okay, watch out for units, kilometers per hour, meters per second. Okay. You recognize all those things? Get your givens correct. Do your thing. You had two questions for homework last night. We're going to spend just a minute going over one of those two questions. We'll go over question number 2 here, and then we'll just draw a couple quick areas of comparison with question number 1. Number 2 says, a 1,200 kilogram car traveling north at 20 collides with a 1,400 kilogram car traveling south at 22. The two cars collide and entangle. First of all, let's recognize that we have a north and a south here, so we have to pay attention to direction, positive and negative. Secondly, what does that word entangle mean? Stay together. We have a little dictionary / thesaurus at the back of the room there. Entangle means stick together. They head off as one object. We want to find the velocity of that one object or of that wreckage. We could analyze car number 1 using impulse. We could analyze car number 2 using impulse. But we're going to choose to analyze this as a system, as an isolated system, in which Pi is equal to Pf. Let's write down some givens here. M1 is 1,200 kilograms. M2 is 1,400 kilograms. We're going to say V is 20.0 meters per second. Is that V1 or V2? Is it the velocity of the 1,200 or is it the velocity of the 1,400? 1. It's V1. Good. Benton, is it V1I or V1F? Initial or final? Yeah, it's before the collision takes place, so it's V1I. Good. We have another velocity here. It is negative 22 meters per second. We know it's negative because it says it's to the south. Is that going to be V1 or is that going to be V2? Nicole, V1 or V2? V2, good. Initial or final? Yep. Before the collision takes place, so it's going to be initial. Good. What's the resulting velocity of the wreckage? What are we looking for here? VF, right, VF. Okay, so if we analyze it as a system, an isolated system, then Pi equals Pf. Is it safe to do this as an isolated system? What do when we find VF here, what are we really finding? The final velocity, yes, but specifically the final velocity immediately after the collision takes place, right? What's the velocity 5 seconds after that? We don't know. Because friction, maybe some other forces as well, have made it by that time a non-isolated system, an open system. Okay, we're finding the velocity immediately after, and we should be good to go. That's an isolated system if we do that. Okay, PI. How many objects do we have? Before. 2, good. So we're going to say M1 V1 plus M2 V2. But we're going to stick a little I on both of those to remind us that it's initial. How many objects do we have afterwards? 1. So let's just make it MV. Let's make it M total V. Because both objects have combined. And let's make it VF there instead of V1 or V2. You want to make it like M3, V3F, you could do that as long as you recognize that object number 3 is really the combination of 1 and 2. Okay, let's sub in some numbers here. We got 1,200 times 20 plus 1,400 times negative 22 equals 2,600 times VF. 1,200 times 20 is 24,000. 1,400 times negative 22 is negative 30,800. These two get combined, and then this goes over by dividing, right? The VF there works out to be 2.62, negative 2.62. Or 2.62 meters per second to the south. Is that good? Like you get your givens right here. Question becomes pretty straightforward actually if you get your givens right. The hardest part is almost getting those givens correct. Watch out for the signs. We're not going to solve number 1 right now, but how is number 1 a little bit different? I mean, it's fundamentally the same, but how's it a bit different? Like there's always little subtle differences between one question and the next. What is the subtle difference between question 1 and 2? Yeah. Yeah, the ball is thrown at the guy, the ball is moving. V1 is 7.5 meters per second. V2I, the velocity of the second object before the collision is 0. And then afterwards they stick together. The guy embraces the ball, becomes one with the ball. They head off as one, just like this. But before the collision, that second term, M2 V2I, would be 0 instead of negative, something like it was in this one. All right? Okay, good. I want to do another example with you here. Example number 2 on the handout that you got on the first day. This one says a 0.006 kilogram ball moving up 3 meters per second north collides with another one moving to the south. Definitely want to circle that. First ball moves off to the south immediately after the collision. It's good when we use the word immediately, because then it's clear that we have what we can consider to be an isolated system. No external forces have had a chance to act. What's the velocity of the second car immediately, second ball it should be, not the second car, the second ball, immediately after the collision? We could analyze the motion of ball number 1 using impulse, or ball number 2 using impulse. We're going to choose to use conservation of momentum to analyze the system. Say M1, 0.0060 kilograms. M2, oh, look at that, 0.0060 kilograms. That actually is going to make life easier for me in a moment. I'll explain how when we get there. Man, I got a lot of givens here. 3.0 meters per second is one velocity. I've got negative 2 meters per second. Negative because it's to the south, that's another one. And then I've got one that's negative 1.0 meters per second. That's another one. What's the 3? A ball moving at 3 to the north collides with another one. Is that V1 or V2? 1. Good, Ben. Ben, V1I or V1F? Good. Parker, the negative 2 meters per second, 2 to the south. Is that V1 or V2? Yeah, good. V2. Is it V2I or V2F? Good. And this negative 1 meters per second, JC, this negative 1 meters per second, is that V1I? Sorry, is that V1, V2? Is it? V. I don't want to call it V3. Oh, wait a second here. Yeah, I don't want to call it V3 because there's only 2 objects there. Yes, okay, that works for me. V1, it's the first ball, I should say, and it's final afterwards. We're looking for V2F here, right? The velocity of the second ball or car, whatever it is. Can't decide what it wants to be. Does it want to be a ball, want to be a car? If we're analyzing one ball or the other, it's impulse. If we're analyzing the system, it's conservation of momentum, Pi equals Pf. There are, Janae, how many objects before the collision? 2. So M1, V1 initial plus M2, V2 initial. Austin, how many objects after the collision? Nope. 2. Right? They don't stick together. It doesn't say they stick together. We have to assume that they don't. So that's going to be 2 terms, M1, V1F plus M2, V2F. All right, I see a shortcut here. Anybody spot it? Tim? Tim? We can cancel out the mass. Why can we cancel out the mass in this question and we haven't been able to do it in any of the other questions thus far? Because it's the same mass. If it's the same mass and it appears in every term, we can get rid of it. Now, this makes the math really, really easy now. V1I is 3.0 plus V2I is negative 2. V1F is negative 1 plus V2F. So 3 plus negative 2 is 1. And then we're going to take this negative 1 over by adding, and it becomes 2. So V2F ends up being 2 meters per second. Is that okay? How is this different from the other courses that we've done so far with this? Like fundamentally, it's the same, right? Subtle differences. How is it subtly different than the other questions that we've done so far? We have 2 objects, yeah, but yes, yeah, 2 objects afterwards, right? So instead of combining like they did in those other courses that we've done, they stay apart. That doesn't make it harder, right? It just makes it an extra term and maybe mathematically a tiny bit harder. Although in this case, because we canceled it the mass, I don't think it's any harder at all. It's subtly different, but for the most part, the same. The thought process is certainly the same as you go through this. All right, I'd like you to take a look at worksheet number 3 that we were working on before. Now we're going to go with questions 3 through 5 on worksheet number 3. Let's take a look at one more example. It's number 3 on that sheet that I gave you on the first day of class here. This one says a 75-kilogram man is standing on ice while holding a 2.5-kilogram ball. The man throws the ball forward at 15. What's going to happen if the ball goes forward? What's going to happen to the man on a frictionless surface like ice? He's going to go backward. Now, what would we predict his velocity to be? Bigger than 15 or less than 15? The ball's going 15 right afterwards. Is he going bigger than 15 or less? How come less? Yeah. Now, if the ball gains 10 momentum, he has to lose 10 momentum, right? So 10 momentum in the opposite direction, right? Well, if they both have the same momentum but in opposite directions, the heavier object must have a lower velocity. A little bit lower or a lot lower? Quite a bit, yeah. Quite a bit, because he's quite a bit heavier, so his velocity will be quite a bit less. Let's write down some givens here. I'm going to say M1 is 75.0 kilograms. I'm going to say M2 is 2.5 kilograms. We got a velocity here of 15 meters per second. What is that? Is that V1 or V2? The velocity of the ball? The velocity of the man or the velocity of the ball? It's the ball, and we defined object number 2 as the ball, so that's going to be V2. V2I or V2F? This is how fast the ball is moving after it's released, right? After the, for lack of a better term, the explosion. V2F. We're looking for V1F, the velocity of the man immediately after. Is there anything else that we have here if we read between the lines? We throw this question into Google Translate. What does it spit out? Yeah, VI is 0. We're not even going to call it V1I, or we're not going to call it V2I, because it's the man and the ball combined. VI, total VI is 0. We could analyze this just doing impulse if we analyze either the man or the ball, but we'll look at the system here. So we'll say PI equals PF, conservation of momentum. We're going to say, I'm just going to say 0. What have I just done there? Why was I able to say 0 for the initial momentum? Yeah, Ben? Yeah, like the guy and the ball are at rest, right? So their velocity is 0, so their momentum is 0. 2 objects afterwards, M1 V1F plus M2 V2F. M1 is 75 times V1F is, that's what we're looking for here. M2 is 2.5 and V2F is 15. This goes over to the other side by subtracting. I end up getting negative 30 equals, no, that's not right, negative 37.5 equals 75 times V1F. And we solve for V1F by dividing 37.5 divided by 75, gives me negative 0.50. We predicted 2 things. A, that the man would go in the opposite direction. We get a negative value, so we were right about that. We also predicted that his velocity would be a lot less than the velocity of the ball. We were right about that. The ball is 15, he's 0.5. Because he's a lot heavier, his velocity must be a lot smaller. All right, I'm going to ask you now to finish up questions 6 and 7 on worksheet number 3. So your homework tonight is questions 3 that we started at the beginning of the day all the way up to question number 7. I know you finished a good chunk of those, so you should have maximum 2 or 3 of those questions to work on.